This situation is emotionally charged, and it's on the verge of a dramatic event. There's no certainty about the exact timing of what's coming. It could happen tomorrow, or perhaps even during this transmission. The event will be striking, like a glowing second sun. Recently, the James Webb Space Telescope discovered a surprising 250% increase in the red supergiant Betelgeuse's brightness, a gigantic star on the shoulder of the Orion constellation. This unexpected behavior has piqued a lot of interest and curiosity. Some speculate that this sudden increase in luminosity may signal that Betelgeuse is gearing up to explode in a supernova. But the exact timing of this remains uncertain. Experts believe the event could occur sooner than expected. Join us as we delve into the vastness of space and uncover the mysteries surrounding this colossal star, a discovery that could drastically alter our understanding of the cosmos. Despite the unfamiliarity of its name, you've probably admired Betelgeuse's vivid, bronze-colored glow shining brightly at Orion's shoulder, part of a well-known star cluster. Its enormity is staggering. If placed at the center of our solar system, its outer layer would stretch far beyond Jupiter's orbit. This colossal star continues to captivate viewers and stand out from most stars. Betelgeuse exhibits noticeable fluctuations in its behavior over time. Due to its proximity to our system, and classified as a semi-regular variable star, its brightness fluctuates predictably, hinting at an eventual breakdown that might lead to a cosmic explosion. Recently, Betelgeuse has become even brighter due to remarkable shifts in its luminosity. Among these fluctuations was a dramatic increase on May 20, 2023, when scientists recorded an astounding 142% increase in brightness, followed by a later update confirming a 150% rise. Harvard astrophysicists from the Smithsonian Center for Astrophysics pointed out that Betelgeuse has now become the 7th brightest star in the night sky, climbing 3 positions from its usual 10th place. From the southern hemisphere, the star shines visibly in the night sky, a stunning sight at the shoulder of the Orion constellation. Dr. Sarah Webb, an astrophysicist at Swinburne University of Technology in Australia, emphasizes the significance of studying Betelgeuse, as it offers a unique opportunity to examine the final stage of a massive star's life cycle, shedding valuable light on stellar behavior before they explode as red giant supernovae. When Betelgeuse eventually explodes, it could become exceptionally bright for possibly about a week, even casting shadows at night. Both amateur astronomers and professional scientists are eagerly anticipating the event. Heidi Morris, a scientist at Los Alamos National Laboratory and president of the Padaro Stargazers and Cosmology Club, notes that the ongoing interest in Betelgeuse's brightness variations is a phenomenon that has intrigued multiple cultures for many years. Currently, Betelgeuse's brightness cycle spans about 130 days, much shorter than its typical cycle that lasts for many years. These rapid changes offer a rare opportunity for astronomers to study this stellar anomaly in greater detail, offering unprecedented insight into the last phases of a star's existence. Betelgeuse's erratic behavior began in 2019, when the star suddenly ejected a portion of its outer atmosphere. These variations in brightness are unusual for Betelgeuse, which has led to questions about whether it is nearing its end and may burst into a supernova. According to a study authored by Dupree and other researchers from Harvard and the University of California, Berkeley, it may take another 5 to 10 years for Betelgeuse to return to its expected 400-day brightness cycle. Since the star has behaved unusually in terms of its rotation speed and light output, astronomers are left to speculate whether these fluctuations are the beginning of the end for this massive red supergiant. Betelgeuse is indeed a massive star nearing the end of its life, exhausting its fuel, and beginning a rapid phase of evolution. As its foundation crumbles under its own enormous mass, it could cause a supernova explosion that would have the ability to dominate entire planets. Despite this, the precise moment of this event remains uncertain. Dr. Pierre, a professor at the University of Cosmology in Portsmouth, notes that predicting the moment of a supernova remains difficult due to the absence of complete historical records and the complexity of stellar evolution. Betelgeuse is currently undergoing fusion processes that are always changing, by fusing elements like carbon, helium, silicon, and eventually iron. As a red giant star, it converts helium into carbon at its core, a process that takes millions of years. Eventually, it will begin to fuse heavier elements until it reaches a point where it can no longer support fusion reactions, leading to a gravitational collapse and possibly creating a neutron star or black hole. While some theorists predict that Betelgeuse's explosion is imminent, historical data suggests that the star has been gradually growing redder over the years, which implies that it could take a significant amount of time before it attains supernova status. NASA estimates that Betelgeuse isn't expected to explode for another 100,000 years, offering reassurance that it is highly unlikely to occur within our lifetimes. Despite the uncertainty surrounding its exact future, the unpredictable nature of Betelgeuse's behavior continues to captivate researchers. Developments in our understanding of stellar evolution are still ongoing. Dr. Sarah Webb reminds us to remain open to all possibilities, even as the likelihood of witnessing Betelgeuse's explosion in our lifetime seems remote. By keeping track of its changes, we may make further scientific breakthroughs that open up new discoveries in the universe. It is important to keep in mind that our observations of Betelgeuse are essentially a glimpse into the past. The star's visible light is over 600 years old, meaning Betelgeuse may have already exploded by now, and we wouldn't yet know it. Although this is a possibility, it is far from certain. History has demonstrated that assumptions in astronomy can be challenged. For instance, prior to 1987, astronomers believed that only red supergiants could go supernova. But that year, a massive blue star in another galaxy exploded, surprising the entire academic community. This shows there is still much to learn, and surprises may be ahead. Observing Betelgeuse, as well as other significant stars, provides us with an opportunity to expand our understanding of celestial phenomena. Even if the explosion is not imminent, the star's unpredictable behavior is still fascinating and reveals important aspects of stellar physics. Currently, Betelgeuse's increased brightness in 2023 has rekindled global enthusiasm, sparking renewed interest in this astronomical giant. The star's erratic behavior continues to prompt intriguing questions about when and how its inevitable explosion will occur. Some astronomers believe that the current surge in brightness is a sign that Betelgeuse is nearing the end of its life, while others caution that the star might simply be going through an unusual but typical phase of evolution. As well as advanced telescopes and observation techniques become more sophisticated, scientists are increasingly able to capture fine details of Betelgeuse's internal processes. The James Webb Space Telescope, in particular, offers unprecedented infrared views of the star's outer layers, revealing patterns of material movement and temperature shifts that were previously invisible. These insights help researchers better understand the turbulence within Betelgeuse, turbulence that may be linked to the buildup toward a potential supernova. At the same time, data from ground-based observatories across the globe is being pooled to form a more comprehensive picture. Instruments like the Very Large Telescope, VLT, in Chile, or the Atacama Large Millimeter-Submillimeter Array, ALMA, allow astronomers to monitor changes in real time with incredible resolution. These teams are tracking not just brightness but also the star's shape and the mass it continues to shed, looking for any signs of collapse. Despite the high levels of attention and observation, the precise mechanism that triggers a supernova still eludes complete understanding. Betelgeuse may be showing signs of entering its final stage, but until the star reaches ion fusion in its core, a point beyond which no energy can be extracted, the supernova countdown cannot truly begin. And when that happens, the collapse will be nearly instantaneous, within a matter of seconds. Some scientists liken the process to watching a candle burn down, uncertain when the final flicker will come, but knowing the end is inevitable. Others remain cautious, suggesting the current behavior could still be within the wide range of normal variability for red supergiants. After all, stars of this size and mass do not follow strict schedules, they follow cosmic rhythms that we are only beginning to understand. What remains beyond question is that Betelgeuse has captivated global imagination. Its recent outbursts have not only triggered scientific research but also reignited public interest in space. From school children to seasoned astronomers, millions now look up at Orion's shoulder and wonder, will we be the ones to witness the explosion? Will the night sky soon gain a blazing light never seen before in recorded history? As methods come online, they allow for increasingly accurate measurements of Betelgeuse, whose brightness varies along with its evolving behavior. These technological advancements provide an unprecedented chance to closely observe a star as it nears the end of its life cycle, offering insights that were once reserved for the distant future. The excitement surrounding Betelgeuse has prompted even those without an academic background in astronomy, casual observers of the stars and night sky, to become captivated by the star's changing light. The sight of Betelgeuse glowing with such intensity in the night sky is a visual reminder of the enormous forces at work in the universe, forces that may soon culminate in the star's transformation into a supernova. The potential for us to witness such a grand cosmic spectacle in our lifetimes adds a sense of wonder as we continue to observe the star. While there are still uncertainties regarding the precise timing of this event, the sheer possibility that it could occur in the near future is enough to keep both enthusiastic amateurs and professionals scanning the heavens. Betelgeuse's behavior has emerged as a major focus of both observational astronomy and public interest. The star's sudden dimming in 2019 was one of the most talked about recent occurrences in the history of astronomy. Astronomers and stargazers alike watched in awe for months as the star seemed to fade, triggering a wave of theories about what might have caused such a dramatic change. Was Betelgeuse on the brink of a supernova? Or was it simply going through a typical stellar phase of evolution? Researchers worked tirelessly to answer these questions, eventually determining that the dimming was likely caused by a cloud of dust and gas that obscured the light of the star, rather than being a sign of an impending explosion. Nonetheless, this event sparked widespread fascination and renewed interest in the positioning of Betelgeuse as one of the most important stars in the sky. Since then, the study of star life cycles has placed Betelgeuse at the center of intense research, with astronomers using every available tool to learn more about its changing brightness and the reasons behind its erratic behavior. The star's present flash of light in 2023 is yet another piece of the puzzle, prompting fresh questions about whether it marks the beginning of its final stages. While the star has undergone variations in brightness throughout its life, the magnitude of these recent alterations has raised the stakes. According to scientists, Betelgeuse could be nearing the point where it will transition from a red supergiant into a supernova. In the meantime, other red supergiants in our galaxy are also under scrutiny. While Betelgeuse remains one of the most prominent examples of a massive star far from its end, there are additional stars, like Epsilon Canis Majoris, that are undergoing similar transformations. Some might even explode before Betelgeuse does. However, as Betelgeuse is one of the most studied stars, it offers an unparalleled opportunity for research. Scientists are using it to find out more about the processes that govern the lives of these enormous stellar bodies. By comparing Betelgeuse's behavior to that of other red supergiants, researchers can refine their models of stellar evolution and improve our comprehension of what might happen when these stars reach the end of their lives. The potential for Betelgeuse to become a supernova has captivated the imagination not only of astronomers but also of the general public. If it does eventually explode, it will be an event of unprecedented scope. The light from the explosion will likely be visible to the naked eye for several weeks, and its brightness might exceed that of many stars currently visible in the night sky. Such an event would be a once-in-a-lifetime experience for anyone fortunate enough to witness it, offering a dramatic and awe-inspiring spectacle that would be forever etched in the memories of those who observe it. For now, we can only speculate about the exact timing and nature of Betelgeuse's explosion. Predictions about the timing of supernovae are notoriously difficult to make, as they depend on a variety of factors that are not fully understood. For example, while some stars may move on from their red giant stage into a supernova in a relatively short time, others may undergo a much slower transformation. Betelgeuse's behavior over the next few years will be critical in helping astronomers improve their understanding of these processes and enhance their ability to predict the future evolution of other massive stars. As we continue to observe Betelgeuse's fluctuating brightness, it will provide valuable data that could one day help scientists forecast the behavior of other stars in similar stages of their life cycles. While the possibility of witnessing Betelgeuse's supernova remains uncertain, the excitement surrounding the star's behavior has resulted in renewed interest in the field of astronomy. Betelgeuse's mysterious changes have sparked the imaginations of people worldwide, prompting many to learn more about the fascinating research on the evolution of stars. In addition, the star's unusual behavior has helped clarify some of the most intriguing aspects of the universe, such as the processes that control the life cycles of massive stars and the forces that shape the cosmos. Betelgeuse's evolution is far from the only astronomical mystery that continues to captivate researchers and stargazers alike. As new technologies emerge, scientists are gaining ever deeper comprehension of the universe, discovering new phenomena and developing models to explain them. Regardless of whether we observe Betelgeuse's supernova in our lifetimes, the ongoing study of this enigmatic star will continue to push the limits of human understanding and inspire future generations of astronomers. The final explosion of Betelgeuse, whenever it may occur, will likely remain a topic of interest and research for decades to come. Even if the star doesn't explode for thousands, or even hundreds of thousands of years, the continued exploration of its behavior will provide critical insights into the final stages of a massive star's life. This knowledge will be invaluable in our quest to understand the life cycle of stars, the formation of black holes, neutron stars, and, ultimately, the fate of the universe. As we continue to watch Betelgeuse, it serves as a reminder of the mysterious and shifting nature of the cosmos. Whether it is dimming or brightening, its dramatic shifts offer a rare opportunity to observe the intricacies of stellar evolution firsthand. The ongoing study of the star holds many discoveries, not only about Betelgeuse itself but also about the fundamental processes that govern the universe. For astronomers and enthusiasts alike, the tale of Betelgeuse is far from over. With each new observation, we advance one step closer to solving the puzzle of the stars. As the astronomical community remains focused on Betelgeuse, each new piece of data adds depth to our understanding, not just of this particular star, but of stellar evolution as a whole. Scientists are now working collaboratively across institutions and continents, combining data from ground-based telescopes, space observatories, and even citizen science initiatives to track every flicker, flare, and fluctuation in the star's light. This global interest has turned Betelgeuse into something more than a scientific subject. It has become a cultural phenomenon. Articles, documentaries, and online forums have emerged, engaging the public and bridging the gap between complex astrophysics and human curiosity. People from all walks of life now follow the star's developments like a cosmic drama, wondering if they might be alive to witness the grand finale. At the same time, Betelgeuse is helping to test the limits of our current technology. Instruments aboard satellites like the Hubble Space Telescope, the James Webb Space Telescope, and various spectroscopic missions are being fine-tuned to study red supergiants in greater detail. Betelgeuse serves as both the subject and the benchmark. New methods developed to monitor its irregularities may one day be used to study countless other stars across galaxies. Moreover, there is a philosophical dimension to all this. The study of Betelgeuse reminds us of the fleeting nature of existence, even for celestial giants. Stars, no matter how massive and powerful, have lifespans. They are born, they evolve, and eventually, they die. The death of a star, especially one as massive as Betelgeuse, is not an end but a transformation. The material ejected during a supernova enriches the galaxy with elements that later form new stars, planets, and even life. So, as we gaze up at Orion and spot the faint, flickering orange light of Betelgeuse near his shoulder, we're not just looking at a star. We're witnessing the final chapters of a titanic life story, a tale written in plasma, pressure, and fusion over millions of years. Whether Betelgeuse explodes tomorrow, in 1,000 years, or 10,000, its legacy is already imprinted in both our scientific record and our imagination. And so, astronomers will continue to watch. Instruments will continue to scan. And people across the world will continue to wonder, what will the sky look like when Betelgeuse finally goes supernova? Because whenever that moment comes, the universe will remind us once again that it is alive, evolving, and endlessly full of awe.